All right, let's do this. Today, we're taking a journey to the most extreme, most mysterious, and frankly, the most terrifying places in the entire universe. We're going inside a black hole. Everything we think we know about how the universe works is built on a set of fundamental laws. But deep inside a black hole, there's a point where all of those laws, all of those rules, they just collapse. They stop making sense. So the real question is, what actually happens when you reach a place where physics itself just breaks? Well, let's find out. Okay, so before we just plunge right in, we've got to get the lay of the land. Our journey starts from a, relatively safe distance, looking at the clues that give away this monster that's hiding in the darkness. So here's the thing. Black holes themselves are completely invisible. They're black on black. So how on earth do we even find them? We look for the mess they make. This incredible, brilliant ring you see is called the accretion disk. It's a chaotic swirl of superheated gas and shredded stars, all spinning at insane speeds as it gets pulled closer and closer. It's basically the black hole's final glowing meal. Now, you might notice something kind of weird. One side of that disk always looks way brighter than the other. That's a really cool effect called Doppler beaming. See, as the disk spins, all the stuff moving towards us gets its light waves kind of squished together, making it look brighter, and the stuff spinning away, its light gets stretched out and dimmed. It's pretty much the exact same reason a siren sounds higher pitched when it's coming at you and lower when it's going away, but for light. And there it is, the edge, the event horizon. Now, this isn't some solid surface you could stand on. Oh no, it's way more absolute than that. This is the boundary where gravity becomes so ridiculously strong that nothing, not even light itself, can escape. It is the universe's ultimate one-way street. Once you're in, there is no coming back, ever. So that dark circle we see in the middle, you'd think that's the event horizon, right? Nope, it's actually the black hole's shadow, and it looks about twice as big as the real thing. Why? Because the black hole's gravity is so intense, it warps space-time around it like a funhouse mirror. It actually bends the light from behind the black hole around it, creating this massive silhouette. It's literally an optical illusion caused by gravity. But oh, the story gets so much weirder. See, most black holes aren't just sitting there. They spin, and a lot of them spin incredibly fast. That rotation just adds a whole new level of bizarre physics to the mix. As we get closer, we're going to enter a region where the black hole isn't just pulling stuff in. It's actually grabbing the fabric of space-time itself and twisting it. Just try to imagine this for a second. A place where you are physically incapable of standing still. Not because there's a wind or a current, but because the very space you exist in is being dragged forward, whether you like it or not. Well, that place is real, and we're about to step inside. This crazy region is called the ergosphere. It's this sort of flattened, oval-shaped zone right outside the event horizon. Inside here, spacetime is spinning so fast that from the outside, it looks like everything within it has no choice but to rotate right along with the black hole. And this twisting effect has a name. It's called frame dragging. Probably the best way to picture it is to imagine you're stirring a cup of thick honey with a spoon. The honey right next to the spoon gets dragged around with it, right? The black hole is the spoon, and the honey, well, that's spacetime itself. And get this bizarre, swirling region holds a truly incredible secret. It's a potential source of limitless energy. There's a theory called the Penrose process that says you could fly a ship into the ergosphere, drop something, and then fly out with more energy than you went in with. You'd literally be stealing rotational energy from the black hole, slowing it spin down just a tiny, tiny bit. Wild, right? Okay, we've seen the violent disk. We've navigated the spinning vortex of spacetime. There's only one place left to go. It's time. We're taking the final plunge, right across the event horizon and into the black hole itself. The absolute instant you cross that boundary, the universe fundamentally rewrites its own rules. Space and time, they kind of swap roles. For you, moving towards the center is no longer a direction you can choose. It's now your future. It's as inevitable as how, for us right now, time only moves forward. Every single possible path, every future, all point to one single destination. So, we've followed that inevitable path all the way to its end. We are now at the very heart of the black hole. And this is where we find it. The thing that has completely stumped physicists for 100 years. We've found the singularity. This is what Einstein's theory of general relativity predicts. A singularity, a point with zero volume and infinite density, where all the mass of the black hole is crushed into nothing.
It's the place where our equations just spit out infinity as an answer, and our entire understanding of physics just shatters.
But here's the catch. In the real world, nature doesn't really do infinity. When one of your physics theories starts predicting infinite results, that's not a discovery. That's a huge red flag. It's the universe telling you that your theory is broken, or at least incomplete. The singularity is a sign that general relativity is missing a piece of the puzzle.
So, if the singularity isn't a real thing, then what is actually at the center of a black hole? Well, this is where physics gets really interesting. Scientists are exploring some truly mind-bending ideas to figure out what's really going on in there.
So we have a few contenders. There's the classic singularity predicted by general relativity, but then you've got ideas like a Planck star. This comes from a theory called loop quantum gravity, and it suggests that matter can only be squished down to a fundamental minimum size. It can't collapse to infinity. Then there's the gravistar idea, which proposes the center isn't matter at all, but a weird bubble of dark energy that just repels anything from actually getting inside. But hold on, there's one last twist. For a spinning black hole, which, remember, is probably most of them, the singularity might not even be a point. The rotation could stretch it out into a ring, a one-dimensional loop of infinite density. And what happens if you try to pass through that ring? Well, that's where things get really crazy. Some theories, and this is highly speculative, suggest that passing through that ring's singularity could be like passing through a gateway, a wormhole, a bridge to another place, another time, maybe even to an entirely different universe. So our journey doesn't really end with an answer. It ends with the biggest question of all. What if a black hole isn't an ending, but a doorway? What or where is on the other side?